Okay, welcome everybody to our second day of our NMOS DMD. And today we're going to be covering on place values. So let's take a look at our table of content. So we have a few things to cover for today. We start off with our decomposition of our place values, followed by your factorization, and subsequently your factors and multiples. Using these three things, we're going to be helping us solve our practice question that will involve a past year NMOS question. So today we're going to be doing something a little bit different today for our practice question. Now, for the decomposition of place values, we can look at certain large numbers as smaller place value terms. And what do I mean by this? Let's say we look at the number 5,432. Rather than looking at this as your 4-digit number, we can actually look at it as 5,000 plus 400 plus 30 plus 2. But yet again, we can still simplify this even smaller. We can instead write it as our 5 times 1,000 plus 4 times 100 plus 3 times 10 plus 2. Look at the digits, 5, 4, 3, 2, all reappearing on the right-hand side. This will be exceptionally helpful if we are looking at your ABCD. So basically an unknown number with all the digits unknown, but we know it's going to be a 4-digit number. So we can call this A times 1,000, B times 100, C times 10, and D. So we can write it in this manner. So what about your factorization? We understand some basic factorizations that will eventually use them in your place values later. So we take out some common terms. Let's look at a basic calculation. 5.4 times 45 plus 5.4 times 55. We notice that there are actually some common factors here. So we have your 5.4 and 5.4. We can take these two 5.4 out by simply writing 5.4 on the outside and leaving the rest of the numbers inside the brackets. 45 plus 55, and we're going to write it as 4.5 times 100. Look at that. Suddenly the calculation becomes much easier. So we have your factorization method here. Now let's look at something else. What about factorization, but in place values instead? So let's say you are now given your terms here, A, B, C plus B, C, A. Rather than actually looking at them as these two 3-digit numbers, we can actually split them into your different place values first. And we have your A times 100 plus, and I'm going to write this a little bit differently. I'm going to be writing this as BC. I'm going to still stick them together because we can still observe them on the right-hand side as well. Plus your BC, rather than writing just BC, it's going to be 10 times of your BC because your values you see here, BC with a 0 at the back. It is basically 10 times of your BC value. Then subsequently, at the end, there is still an A. We need to add it in. Combine them together, you can even simplify them to 101A plus, then after that, we keep the BCs together as well. 11 times BC. We can even use this for our subsequent calculations, which we will in your factors and multiples. So we observe our next part over here, where we can do some determining of factors after some factorization. Let's look at another example. A, B, C minus B, C, A. So if we notice in this case here, we can decompose them into our smaller terms. Once again, we get 100A, and we are going to be adding your BC. Then subsequently subtracting away 10 times of your BC, and we're going to minus the A as well. So from here, we're going to get our 99A plus your, minus your 9BC minus 9 times BC. So how is this actually going to be helpful? Let's say I were to factorize this a little bit further, and I'm going to get 9 bracket 11A minus BC. And we are later told that this difference over here is something a little bit special. The difference here is a multiple of 11. Notice that this cannot be a multiple of 11, considering that 9 itself, of course, is not a multiple of 11. 11A within your bracket here is a multiple of 11. And this entire section must actually be a multiple of 11. Knowing this, we can even determine, let's say, the possible values of your BC. Okay, for example, okay, we know that here 11A is already a multiple of 11. BC must also be a multiple of 11. Must be multiple of 11. So sometimes just by doing some decomposition here and maybe even some factorization here, we can even try to go and determine the factors or the multiples of the outcome, where it can also be helpful inside our next question and even your DMD later today. So X is a 3-digit number and Y is a number obtained by writing the digits of X in a reverse order. So let's give you these two numbers first. X can be written as A, B, C, and Y written as C, B, A. You are told that the sum of these two numbers leaves a remainder of 100 when divided by 101. So let's say I would add the X plus Y together, and it gives us A, B, C plus C, B, A, where you can decompose them into 100A plus 10B plus C plus 100C plus 10B plus A. We can even rewrite them in this order here. 101A plus 101C plus 20B, giving us 101A plus C, then after that, plus 20B. You are told that when your X plus Y is divided by 100, your remainder is divided by 101, your remainder is 100. And if you look at the numbers over here, this section, let's highlight with a slightly different color. This itself already has to be your divisible by 101, meaning that the outcome, the remainder that is left behind here actually comes from your 20B. We're in fact able to already determine straight away that 20B must be equal to 100, where B equals to 5. Now, they said as well that X minus Y is going to be a positive integer that is also a multiple of 8. So let us go and write down our terms out again. ABC minus CBA. This is going to give us 100A plus 10B plus C minus 100C minus 10B minus 8. And with some cancellations here, we can already observe something that can make it easier for us to count. Look at the 10B. 10B can be cancelled out, and we combine our A and C together. It's going to give us 101A. Okay, sorry. We'll get 99A. 99A. And we're going to get your minus 99C. So this can even be simplified to 99A minus C. Since we're already told that it's a multiple of 8, where would the multiple of 8 come from inside this question? It cannot come from the 99 because we know 99 is not a multiple of 8. It can only come from A minus C. This means A minus C has to be 8, where there are only two possible outcomes. Whether you can write it as your 8 minus 0 equals to 8, or 9 minus 1 equals to 8 as well. However, if we look at this specific value, C, 0, can C be a 0 in this case? So in our opinion, we would not actually take this as an answer because C, B, A, we consider Y as a 3-digit number as well. So that's why we will actually say that C cannot be 0, and this will be rejected. We can only get the answer 9 minus 1 equals to 8. And since 9 minus 1 equals to 8, this means that A equals to 9 and your C equals to 1. This means there is only one final outcome in the end. The final answer here should be 9 from A, 5 from B, and C, 1 from C. The final answer, 951. So you can see how your place value manipulations, your decomposition, your factorization, and your factors and multiples here can actually help you solve a certain question. And in fact, many of these tips and tricks will be very helpful when you do your DMD questions later. So once again, please be reminded that you need to answer all 3 questions. You should really try all 3 of them out. Even if you cannot, at least attempt a couple of steps. Number 2, send your answers inside the group chat and we will be actively marking your papers. Last but not least, please take note of the solutions that will be sent out to you in the next day.